Module 19.3, Day 1, Tangents and Circumscribed Angles. Content Standard. Identify and describe relationships among inscribed angles, radii, and chords. Language objective. Work in pairs to identify tangents and points of tangency. Proving the tangent radius theorem. Tangent radius theorem. If a line is tangent to a circle, then it is perpendicular to a radius drawn to the point of tangency. So this is the tangent line, and this is the radius, and so this point is called your point of tangency, and the radius and the tangent line form a right angle, and they're perpendicular, so then it's 90 degrees. Okay, so then here is the proof. Line M is tangent to the circle at point P. Prove that the segment CP is perpendicular to line M. Right. Part A, use an indirect proof. Assume that segment PC is not perpendicular to line M. There must be a point Q on line M such that CQ is perpendicular to M. If CQ is perpendicular to line M, then triangle CPQ is a right triangle, and the length CP is greater than the length CQ because, well, if this is a right angle, then that means that CP is because the segment CP is the hypotenuse of the right triangle, and then line M is the tangent line. It can intersect circle P at point P, and all other points of line M is in the exterior of the circle. This means that Q is in the exterior of the circle. You can conclude that CP is greater than CQ because CP is the radius of circle C, and this contradicts the initial assumption that point Q exists such that CQ is perpendicular to line M, because this means that CP is greater than CQ. Therefore, the assumption is false, and CP must be perpendicular to line M. Right? Okay, let's go to number 3. Set both lines in the figure are tangent to the circle, and segment AB is a diameter. So this is AB diameter. Okay, what can you conclude about the tangent line? Well, if this is perpendicular to, this is the tangent line, so it's perpendicular to the circle, and this is also another tangent line. It's also perpendicular to the circle, and then they are perpendicular to the same line, which means that the two tangent lines are parallel to each other, because the interior angles are supplementary. Right, so let's go to the triad. Refer to the figure for problem 1 through 4. Segment AB is tangent to circle C at point B, and segment AD is tangent to circle C at point B. So before we go on, so since it's tangent, okay, this means that this is a right angle, and this is also a right angle. Right? Determine the angle measure. So we're looking for the angle ABC. So we're looking for the angle ABC, and we see that then is tangent to the circle, and this is the radius. So ABC is 90 degree, Now we're solving for the angle DCB. So DCB, and then these two are tangent to the circle. So then these two are supplementary. So then it would be 180 minus 40 degrees. So then this is 140 degrees. Okay, let's go on to number 3. We're looking for the angle BDA. So we look for the angle BDA is this angle here. Well, we know that angle C here is 140 degree, and this form a right angle, and then these two are radii. So that means that this small angle here and this small angle are supplementary. So they are congruent. So we can take 180 equal to 140 plus, let's call those two angles x. So then there's two of them, so we have 2x. So then it's 40 equal to 2x. So x is 20 degrees. So then each of this smaller angle here is 20 degrees, and we saying that this angle is 90. So then this part here must be 70, and this is also 70. So we're looking for BDA is 70 degree, and so now we're looking for the angle CDB. So CDB, so we solve it up here. So then CDB is 20 degree. Okay, so then this is similarly to the one we worked out before, given that these two are AB and AD are tangent to the circle, and these are radii, so this form a right angle, and this form a right angle. So we're looking for the angle BCD. So BCD is this angle, so we say that these two are supplementary. So we take 180 minus 32. So let me double check. So 180 minus 32 be 148 degree. Okay, and then now we're looking for CDA. So CDA is this angle here. So then this is a tangent line, and this is the radius. So CDA is 90 degree. And for number 7, looking for the angle BED. So BED is this angle here, right? So then we're given that this angle BCD is 148, and then that's a central angle. That means that this arc here is also 148. So then this is called an inscribed angle, so it's be half of the arc. So you take 148 divided by 2. So then this is 74 degree. Right, okay, let's go on to our next one, number 8. Okay, number 8, we're looking for DBA. So DBA is this angle here, right? Okay, so then in order to solve for that, well, we need to solve for this smaller angle first. Okay, so then let's call that x. And similar to the previous example, these two are radii, so then these two angles are congruent. So we take 180 equal to 148 plus 2x. So then 180 minus 148 gives us 32 equal to 2x. So then x is 16 degree. So then for BDA to take 90 minus 16. would give us 74 degrees. Okay, so then that's the end of our module 13.1, day 1. Your bookwork is number 1, 2, 4, and 5 through 8, all of it. And we have our new module 13.1 HRW, and you are to copy down notes for 19.4, day 2.